Hello, calculus. I told you guys I would make a little tutorial and go over some of the things we did on our Zoom meeting. Hopefully, the Zoom, you got some good information and had a chance to ask some questions. If you did not join the Zoom meeting or was not able to, um, this might clear up some of the things that maybe you're wondering, maybe you haven't tried yet or missed on the Zoom. So, the first two questions are just taking the antiderivative, which is used in the third question uh, to find the area under the curve between two x values, which are bounds. So we're gonna go jump right into it. I'm also linking on the assignment some practice that I found online for the properties of integration. So check those out. And you should have all you need right now to be current with kind of where we're at. So the main rule for integration, or the antiderivative, is the same thing, is to like the reverse power rule. So in general, if I have something like 2x to the power of 2, if I'm going to integrate this, I want to find out what number or what function would I take the derivative of to end up with 2x squared. So if I were to take the derivative using the power rule, you'd have to decrease my exponent. So I know that this would have to be a power of 3. The tricky part is here, you're going to want to know what number is in front to get 2. But the easiest way to do that is to, instead of decrease, but increase the exponent, but then also divide that number by whatever exponent you increased it to. So in this case, it would be 3. So now you see if I took the derivative of this function, I'd bring that 3 down and it would reduce with the 3 in the denominator to be left with 2. So doing that in the first example here, you're doing it piece by piece. So I'm going to increase the 5 to 6. Then I'll divide the 24 by 6, because if I were to go backwards and take the derivative, once again, the 6's would cancel and I'd be left with the 24. And then this one would be x to the 5th, then 20 over 5, minus 12x to the power of 3, and then I'm going to divide by 3. And then because this is indefinite integration, meaning there is no bounds, this is the function that represents the area, but we always have to put a plus c, some constant. Because if I were to take the derivative of this function, that c would go away. It could be anything. There's an infinite number of functions that could be the indefinite integration. And just reducing this, 24 over 6, you get 4x to the 6th. 20 over 5, you'll get 4x to the 5th minus 4x to the 3rd plus c. And that's your answer. This is the function that represents the indefinite area. For the next one, we'll write x to the 5th power, and then we'll divide the 25 by 5 plus x squared, and then we'll divide the 6 by 2 plus c. So reducing this, we'll get 5x to the 5th plus 3x squared plus c. Now, continuing this process for the fundamental theorem of calculus. Okay, this is what I'll call FTC, fundamental theorem of calculus. This is when you're actually finding an exact area under the curve between the numbers 0 and 3. So we're going to take the antiderivative of this, and it will be x to the 3rd and 2 over 3 minus 4x squared and then divided by 2 plus x. Now you can put the plus c, but the c is always going to cancel out, because what we're going to do is we're going to evaluate this at 3 and 0, which are the bounds of my function. And it's always the upper bound minus the lower bound. Upper being 3, the lower being 0. So doing this, I'll have 2/3, insert my upper bound, cubed, minus 4/2. Well, 4/2 is just 2, so I'm just going to write 2. 2 times 3 squared plus 3. So that's inserting my upper bound. And then I'm going to subtract from it the value when I plug in 0. So you can see that I'm going to write it out, but this is really nice because when I plug in 0, everything's going to equal 0. So minus 2 times 0 squared plus 0. So that whole thing is just 0. And that's just because we had a bound of 0. Sometimes you'll have a value. And when I compute this value, we'll get 27. 3 to the power of 3 is 27 times 2/3 minus 2 times 9, which is 18 plus 3. Okay, and we can reduce the 27 and the 3 because 3 goes into both of them. This would be 9. So this becomes 18 minus 18 plus 3, which just gives me an area of 3. So this is the area between x equals 0 and x equals 3. And that's how to evaluate a definite integral. That's called the fundamental theorem of calculus. And it only works when the function is continuous. Because then we know that the area is uniform underneath it and there's no breaks in the graph, no asymptotes or anything like that. So, and everything we're going to be dealing with here, the functions will be continuous. So it's kind of more of a side note. That's it. Try the assignment, submit it. Everything here forward is going to be worth points. So those of you that are looking to increase your grade, please submit. Show work, answers, not just answers, not enough. There's a lot of work to do here. So good luck. If you need any questions, if you have any questions, please reach out to me. Hope all of you and your families are well, and I'll talk to you soon. Bye-bye.